Dzień dobry.
Yay! Thank you.
So, yeah, basically, I work as a consultant. I work with New York Times. I'm a lead developer there right now, but I have a lot of open source projects that's probably more familiar to you guys, like Playgrounds for Objective-C. I have this indie app called Foldify that was popular a couple of years back, but mostly focusing on making teams better. So when I get hired as a consultant, it's usually in more architecture decision roles and thinking about how my time can be multiplied for the whole team. And that's what I focus on. And this is the talk that I think can help everyone doing iOS save a lot of time, not just for themselves, but also for other teammates. So let's talk about metaprogramming in Swift. We need to start with what metaprogramming is, really. And let's look at Wikipedia, which is always the best source for programming knowledge, right? So in Wikipedia, they say that metaprogramming is ability to read, generate, analyze, and transform other programs. But in fact, like it usually happens in real time, right, in runtime. But what we really use metaprogramming for in most languages is to generate boilerplate code, so avoid repetitions. And a good example of that is Ruby. Ruby is a very beautiful language for easy things and a very hard language for complex projects because it doesn't have types. But it has a beautiful metaprogramming DSL. And here we have an example. I don't know how visible it is, but basically we have two functions. And this is just printing. Obviously, imagine that this is more complex code, that we have some similar logic that only differs by a couple of small argumentation changes. And how annoying would it be if we had to write the same pattern over and over again and only variate it based on like a couple of arguments? It's a lot of pain. So in Ruby, metaprogramming is the first one of the major features on Ruby. So you can actually do something like this. So you can define an array, and when the project is run, for each item in the array, you generate a new function, and that function works exactly as you would write it in by yourself, and you can just differentiate arguments automatically. So you write it once, you test it once, and if you find a bug, it's fixed everywhere. The standard way without metaprogramming would be to have the same patterns across your whole code base, and then if you realize that you made a mistake, which happens, we all know too often, you would have to go and find all those references, change that to fix a single bug, which is very annoying. So Ruby, what's beautiful about Ruby is that it's it's extremely flexible, but there will be some issues that I'm going to mention that this allows you to create that are even worse than repetitions. So why would we want metaprogramming in first case? What are the reasons to have metaprogramming in Swift, which is a strongly typed language, right? For some reasons, Apple didn't do it, so there has to be good reasoning for actually adding it on top of the language. So if we look at how we work every day, the kind of tasks that we do for mobile applications, they're usually pretty simple tasks, like we need to create new model objects for our applications. And that usually is useful to be able to equate them. So we want to compare whether an instance of the same class is equal to another instance. So we can do stuff like caching, avoiding doing unnecessary side effects when something gets assigned again. And there's lots of things where equality comes in hand. When you have equality, you have hashing, right? So being able to put something into a dictionary requires you to be able to calculate its hash value for each object that you want. And oftentimes, you might even want to store like view controllers in a hash table because it might be an optimization. So there's a lot of use for those two use cases. Data persistence, a big one, right? We want to be able to persist the state of the application and restore it after the application gets restarted. JSON parsing, I mean, a new library for JSON parsing used to come out every week. So we have, I don't know how many we have in Swift, like 20. 90 of them have operator overloading, like a new thing for a lot of Swift or iOS developers, so everyone is using it. writing and updating testing mocks and stubs. In Objective-C, we had runtime, so we were able to use things like OC Mockito and other libraries that would just use runtime to fake implementation of specific protocols, specific objects, but now we have to create our own by hand. So we need to use a lot of protocols. We need to implement those protocols as stubs and tests so we can simulate different scenarios. There's a lot of simple tasks that in 99% of cases are the same. Like if we think about how equality and hashing works, it's really the same thing for each property in 99% of cases. For each property, we equate them. If the property is different, that means that the whole object is different, right? So we can just say no at that point. The same for hashing. We just get all the properties and we concat their hash values. That's basically it. So why do we have to do the same thing in 99% of cases across the whole code base? It feels like really not something a programmer should do. It's basically describing an algorithm and just having it feed the types information. It should automatically do it for us, right? So we keep writing this useless code instead of focusing on what matters for our users and for our business, which are features, not the boilerplate. So with metaprogramming, we can adhere to dry principle more, right? Because if I say that equality is basically comparing all the properties of my types, that's an algorithm. That for each property, I want to see if they are equal. If they are not equal, the objects are not equal. So rather than having to repeat ourselves, we can write one algorithm description and then have it applied across the whole code base. So the description for equality would be like 20, 30 lines of code for all like 99.9% of use cases, and then it can be applied on tens of thousands of lines of code. So we can adhere to dry principle. If we have bugs, if we find mistakes, it's going to be automatically applied everywhere as well, rather than us having to go and find it. So we can write it once, we can generate corner cases and write tests for it, see if our metaprogramming algorithm works correctly in those test cases. If we change it, we can still run the old tests and see that it's still working. So it eases maintenance cost, which is great. And more importantly, avoiding human mistakes, which I'm going to talk about more in a second, because that's really crucial for me. When you work in big teams, it's not about it's not about being hype-driven development, just grabbing new technologies and throwing everything into the project, having 100 pods. It's how can you design something that's hard to break? How can you design things that other programmers, it makes it easier for other programmers to do things correctly rather than doing it incorrectly. So that's a big challenge for architecture decisions. So how can I make the architecture easier to do right rather than wrong? And human mistakes is everyone does it. Like, doesn't matter how experienced you are. If you can avoid opening doors for making stupid mistakes, you should always do it, because doesn't matter if it's a lead developer, a senior developer, a junior developer, everyone makes a lot of mistakes. And sometimes you work crunch, you work 14 hours a day. And even the best developers just make some ridiculous mistakes, and then sometimes that doesn't come up until production. So you want to avoid that as much as possible, make it as easy as possible for other developers. And what's interesting for me is when you have metaprogramming, you can experiment with different architecture choices, because oftentimes you have things that are simple. Like, there are simple concepts, but they are not easy to do because they require a lot of extra work. Like, let's say you come up with an architecture pattern. Like recently, the iOS newsletters had a talk about typed identifiers. So rather than using strings for things like emails, passwords, they create concrete types, like phantom types, for example. But not even phantom types, because it's only reserved for emails and it's only reserved for passwords, so you can never mistake them. But that requires you to create a new type for each of the fake types, because Swift doesn't have feature for that in the language. So it's a lot of boilerplate if you want to keep growing it. But in fact, if you have metaprogramming, you can make a simple template for it, and you can just define the pattern, and then it's a one-liner rather than having 10 different lines and different initializers and dealing with all the boilerplate. So it's interesting to free yourself from because otherwise you wouldn't do some of the architecture choices because there's so much boilerplate involved, and you don't want to create a custom code generator for every single new idea you have because no one will use it, and it's going to be hard to maintain. It's just pain in the ass. So we want to be able to experiment with architecture choices. We want to come up with ideas that make it harder, for the programmer to break, but doesn't make it harder to maintain it. So it's a fine line there. And avoiding human mistakes is really what it's about. And a lot of people, when I released the tool, well, not a lot, a couple of people were saying like, well, what's the point? I mean, it's generating code. I don't have problem writing equality. I don't have problem writing hashing or JSON parsing or data persistence. It's simple after all. It's not really complex. But this isn't about whether it's complex or not. The problem isn't writing it. What's more important is to maintain it. So let's say I create a new object, right? I create a new class for my data model. And it's all great. I wrote equality. I wrote hashing for it. And then I move on to another feature. Another developer comes to the project, and they start modifying that class. And they add a new property. But they forget to update equality or hashing, either one of them or both of them. And now the biggest issue here is there is no compiler warning because a property you might not be interested in the property equality because that might be a transient property. But this is actually a very rare case. Most of the time, the data models are simple and you compare everything. So what happens now is the project keeps working. It's still working fine. It compiles. The tests are running. Everything works. But if your object is used for something like, for example, cell height cache, which is what we do at New York Times. So for each article, we calculate the height once, and then we store it. We have a hash value, and we store the height so we can avoid unnecessary and very complex tasks because text layout is actually pretty complex. So the project runs. It seems fine when you run it, and then obviously it goes to production because it's hard to simulate. Data sets that will create bugs like this. So if you had like 10 properties, you added one property, you're not going to generate every possible scenario of the data that you get, right? So it goes to production, it's deployed, and then you get a bug report that this cell is cut off. Part of the text is not visible. And now, why is that? Like, what is happening? I mean, it seems fine. When I run it, it works for me. I mean, it works for me. And it takes a long time to realize that you forgot to compare that property. And it costs you, in your company, in the process, it costs you a lot of money, right? Because it has to go to production, users see it, they get annoyed, they cannot read the article fully, then the QA has to reproduce it, they report it, the data changes on the server, and now suddenly you don't have the data set that was there before that was causing the bug. So you need to go and figure out what exactly could have happened. And like missing a property is usually not the first idea that you have. So it takes a long time to figure out what's the core of the problem. So until you find it, it's probably a couple of days past. And it's it's money and it's time wasted that you have been able to use otherwise. So it's really hard to track. So with metaprogramming, that's not gonna happen because if you had that automatically generated, there is no way to make that bug. To avoid a property, it would have to be explicit. It's much more controlled and it's automatic, which is always great. So let's look at what's available as like metaprogramming in Cocoa. It's not like, it depends how you call metaprogramming, but we have this two functions. I'm still talking Swift 3. I don't use Swift 4 yet. It's in beta, so let's look at how it looked before, right? So we have key value coding, and we have like key path observing, right? Key value coding was very useful in Objective-C, especially with the custom operators where you could do things like unions of objects. You could join and make unique arrays. A couple of different features that you could use very well. So it was very nice. And Objective-C obviously had very powerful runtime and reflection. Like a lot of the tooling that we use, for example, aspect-based programming, which is like there's a library that I think Peter Steinberg started that allowed you to inject behavior into existing classes. So like for view controller, before or after view will appear was called, you could inject some custom skinning to your controllers without having to subclass, without having to override the functions. So it's extremely powerful. Everyone used Swizzling, and then everyone hated Swizzling because they used it wrongly for good reason. Swizzling is risky, so better to avoid it. Key value observing, obviously that was very popular before, I think, iOS 4. It started changing once the closures were introduced, so it kind of went away a little. It's not as popular as it used to, mostly because there are better patterns that we can use, safer patterns. And key value coding, which is what I mentioned. This was like extremely useful and powerful for data mapping. I have this library called Property Mapper that relies on key value coding very much. And that allowed me to do like a very nice DSL syntax for my classes and just leverage key value coding for dealing with core data. It has a little different, the way they set properties is a little different. So dealing with core data, dealing with normal types, very powerful feature. But the thing is, most of this is not available in your Swift projects as long as you want to write pure Swift. And anything else, I mean, unless you inherit from Objective-C classes, most of those features don't work. What's the point, right? The whole idea of using Swift is not to write Swifty Objective-C. It's to use the new language, new patterns, not inherit from the old ones and just have a different syntax, right? You lose all the features if you keep using Objective-C classes as the base. You don't have value semantics. You lose so many. It's just not the point, right? It's not good for us. So what is available in Swift? And really what's available outside, well, there's key value coding in Swift 4, right? Key value paths are different, basically. But Swift reflection is like the core feature that's available for us as metaprogramming. But the thing is, it allows us to learn about the types that we use, the instances in runtime, which is great. You could do like a property grid for your type, so you could just pass in an object and then read it and have like all the description of the object. But it's read-only. You cannot modify it through the reflection API, so you cannot have a property grid. So a property grid is basically lists all your objects, variables, and then you can tweak it. That doesn't work because there is no write capability. Maybe it will come later, but I wouldn't have high hopes for that. And unless you start interacting with Objective-C, that doesn't help you much. So you could use reflection to read it, and then you could fall back to Objective-C if your class is inheriting from Objective-C to have the right capability. So I mean, at that point, you could just use Objective-C programming pattern. It's very easy to use. You just reflect an object, and you have the mirror. And there will be more powerful features in the future. I spoke with Joe Groff, which is a Swift compiler engineer. And one of the things he mentioned is they want to be able to derive equality and hashability, similar how Haskell does it. So it would happen automatically for us. But that's not high priority. We have bigger problems. And they also want, one other thing that's very interesting is they want to add a macro system. So macro, not as in C level macros, which were awful to debug, impossible to reason about. You couldn't step through the debugger with it, very annoying. But more like Lisp macros and Rust, they have concepts that basically you just get the abstract syntax tree fed to your Swift code, and you can generate more code out of it, which would be nice if you could debug it. If you could debug anything, really. I cannot even run PO object right now in my project, so that's going to happen very soon, for sure. So what are the problems with metaprogramming? And this is why a lot of people, when I introduced the tool and I talked about metaprogramming, were like, I don't know if this is really the way to deal with it. So in most languages, it's untyped. It's usually based on strings. As you saw in the Ruby example, we had an array of strings to define new methods, and that's not very convenient. It's hard to debug. There is no compile time errors, so we can have some metaprogramming code that doesn't actually execute, and you wouldn't get a build failure. So you expect the behavior like with aspects, right? You would expect the view controller to be skinned, but that code never executed. Everything's still compiled. Nothing happens, right? So you don't get any feedback. You only get feedback if you test the exact scenario you wanted, which isn't very convenient because we don't test very well. And it's runtime evaluated, so inconsistent upstate is the worst thing to do. Like the debugging, you can live with like lack of debugging. You could add some prints, you could do different kind of things. You could do asserts, a lot of stuff. But the problem is that inconsistent state, because that can fall through the cracks of your manual testing, your QA team, especially for like more clever ways of like solving the problems when you use metaprogramming. And that's the worst, because you deploy a project and you find a bug in production, which is like the worst possible case for anything, really. You don't want the user to see your mistakes. You want to, like, if QA finds it, if they hate you because they have so much work, that's fine. If user finds it, that's not fine. If the CEO finds it in production app, that's even worse. So the question is, do we need to wait for Swift 6, 7 until we can stop writing this boilerplate, until we stop doing those human mistakes? I don't think we do. I think the thing is, Apple has so many priorities that they need to work on, like Swift compile times, for example. Like that's pretty big, right? We would all want Swift to compile faster. Like if it worked as fast as Objective-C, that would be fine. That would be fucking awesome. And right now it's not. It's really slow. And it's also a tedious process. They have to draw, you have to go through Swift evolution. A lot of stuff gets approved, but it gets shelved or it gets rejected because not everyone is happy with the solution. So I don't believe that we have to be bound by the platforms that we use. I feel like we should just, if we have an idea, if we see a problem, we should just fix it, which is why I created this tool called Sourcery. And I always say, I normally do TDD, but how my open source work is created is pain-driven development. So almost every project that I have open sourced was because I was pissed off at something. I was pissed off at having to do the same pattern over and over again in different projects, especially when you consult, when you work in agency, or you are a freelancer, you change projects a lot, and then you go into a new project and you have to do the same shit again. And then you go into another project and it's the same thing again. And then another and another. It's like, why? Why do we have to repeat the same patterns? It doesn't make it better if I write it 20 times in a row. It doesn't make the 20 times better than the first one. It's the same crap. So pain-driven development is why I create my tools and why I open source it. So you don't have to feel that annoyance that I do. So what is Sourcery? So Sourcery is something between metaprogramming and code generation. It's kind of both in a way that Sourcery scans your source code, scans your normal Swift code, and it creates AST, so abstract syntax tree for each type in your project. And then those types are fed into templates. I'm going to talk about templates more, but it's fed into a template, which is just a description of your algorithm that you want. And then you can, based on the information about the types, you can generate more Swift or anything else for that matter. And so it's like a middle ground. There is no code dependency added to your project. This is not a framework. You have to think about Sourcery more as a preprocessor rather than having another pod that will slow down your build times. It's not gonna slow down your workflow. It's not gonna slow down your application load. There is no code that's included in your project other than the code that you tell it to generate, which is very useful. And that means that at some point, if Sourcery doesn't work for you anymore, you can just remove the tool, and you can keep the code that you generated, and you can just tweak the code by hand. So it's not hard dependency. It's not like it's gonna break it, make it or break it, right? You can remove it at any time. Your code will still work fine. You will just have to manually update it later on. So what are templates? That's like, yeah, templates, I want to write Swift. So because it's AST-aware code, we need a way to express what we want to convert. Sure. And we support 3 different templating engines. We have Stencil, Swift, and effective JavaScript, for those that like JavaScript. And it's the architecture of Sourcery is very modular. You have separate, basically the scanning is separate from generation, so you could bring your own templating engine very easily. And Stencil is created by Kyle Fewer, and it's a simple language, but it's a one that I recommend people start with. It's not like a real programming language. It's very limited, but the reason I recommend it is usually the use cases for boilerplate generation are simple. You don't want to bring too much complexity into your templates. It's better to keep it very straightforward. And if you have to write very complex templates, there might be a sign that you're abusing the idea of metaprogramming or code generation a little. So this is my recommendation to start with. We also have Swift templates, which is actually was contributed by Kruno, which is the author of Eric Swift. So he contributed it. I played with it before. Basically, what we do is we get the things from inside the brackets, and this is just real Swift code that's just extracted and compiled and run. So it's like 100% Swift. You can do anything you can do with Swift. So that's very powerful. Obviously, this is going to be the slowest one because it's Swift, and Swift is fucking slow. But it's handy for a complex templates. And we have effective JavaScript templating, which is obviously JavaScript. The thing about this is there's a lot of tooling. And if you are familiar with it, this is going to be convenient for people that already know it. And so that's like the tooling part is the more important because you get all the syntax highlight and everything. So Sourcery has, it's actually powered by Apple-owned SourceKit. So the same thing that scans your code in Xcode, it's used for getting the abstract syntax tree. But on top of that, we are adding additional parsing because they don't care about some of the features. So like they don't scan the associated values for enums. They don't care, they don't use it. We do. So we have to add a lot of parsing on top of it. And it generates regular code. There is no runtime involved whatsoever. You just write, it just does what you tell it to do. It's compiled and it's typed. So it's normal Swift code. It's not opinionated by my coding style. Whatever you want it to look like, it will look like that. It doesn't have to even be Swift. You could generate metadata for dot files. You could do a lot of different things. And it has immediate feedback, which means it creates templates in real time. I'm going to show you a quick demo in a second. So as you're writing, like you can do it for introspection. When I get hired, I often get hired to do code review on the whole project. And the first thing I do, I want to see the complexity. I want to see what are the split between types and value types and classes and stuff like that. So here I'm inspecting New York Times code base. And as I'm typing, it's in real time. It's giving me information about the project, which is very convenient. So there's lots of use cases. It supports annotations. So as you create a template, you can, if you want to skip a variable, you could just write Sourcery skip equality, and it's going to skip that specific variable. But it's explicit. You have to be explicit about it. So it allows you to tweak how the template execution works, which is convenient. It supports inline code generation. So if you need to generate NS coding, which requires you to generate code inside of your classes, you can have a marker there, and Sourcery, once it's run, is going to inject the code directly into your file. And how do you integrate Sourcery? It's pretty simple. You add a build first for your project, and a lot of common templates are distributed with it. And when working on new templates, you want to use the daemon because it will give you real-time feedback, which is much more convenient. And some of the bundled templates are equatable and hashable, enum cases and counts. So you get all the enums enumerate as an array. You can get lenses if you like to use functional composition. You can get test mocks, diffing for properties. And for example, if you work on the server, Swift on server, you can get Linux main generated. And decorators. The list it's very long. I'm actually going to show this live, so I'm going to skip this. Is this going to slow down my build times? Like, we are in very bad situation with Swift build times. It's getting better and better, but still, this is a big concern. So it's a very fast parsing. It uses caching. So if your file didn't change, it's not going to rescan it. It's just ignore it. It's much simpler to scan the way Sourcery does it. It's much easier than what Swift does because it doesn't do a lot of multi-file processing. It has some phase to consolidate the results, but in the end, the cost of it is negligible. So the first run is a little expensive because it has to build the cache, but after that, like on New York Times, it's less than a second addition, and so completely negligible. Definitely not something I would concern myself. Like, our build times is like 2 minutes, and Sourcery takes less than a second. Yeah, you don't feel that. Let me show you a quick demo. So actually, I need to change how it's displayed. So I'm going to show you a real use case before I show you the demo. So how many of you do TDD? Okay, not as many. Okay, but the problem is a lot of test-driven development expectations are about equality. So you compare two objects and you hope that they are as you expected. So what happens if they are not? Here is an example. You get, can you see it? Yeah. So it's expected to equal wall of text. In the left side, you can see how much text there is. So it's basically going to print your left object and your right object. And if you have a lot of properties, if you have sub-objects, if it's using composition, it's a shit wall of text. And good luck finding what's wrong, right? Which property is wrong? Like, what's the difference? So it took me 30 lines of templating to write property level diffing. There is a custom matcher that I wrote for myself. So if I run this again, which already has the matcher, you'll see what happens. So rather than having the freaking wall of text, now you see, because we are comparing two arrays, so now you see that at index 0, a variable called name has expected y instead of z. So instead of having a wall of text that you need to scan by either copying it somewhere and like diffing or just manually trying to do it, you immediately get the result. And you see which index in the array, which property, and what is the expectation versus what is really there. So it saves you a lot of time when doing TDD. But let me show you how the daemon works. So I have this, let's see. So I have the watcher here. I have a demo project. I'm going to open the watcher, and I'm going to open the demo project here. And I'm going to use the visual code for writing it. So, okay, let me show you. So I have this project. And in this project, really, I only have the main file. So I'm going to actually, let's keep it. So I have the template here, code generated and templates. So I have the hello stencil, and on the bottom you can see the result. I could actually change the font size. Keyboard settings. Okay, that's going to be better. And I'm going to collapse this. So font types all count. So if I remove the class and I save the file, immediately you get real-time update. So if I were to add multiple classes, I can see that the types are now 3. So that's very convenient. But if you want to do something more interesting, so I have a template. We don't have a lot of time, so I'm just going to copy it here. So for type, in types that are structs, I'm gonna do it like this. For types that are structs, I'm gonna do an extension. I'm gonna create a static function that equates left and right side of the same type. And I'm gonna use stored variables. And I'm gonna, for those stored variables, if they are not annotated with skip equality, I'm gonna generate equality guard. If the properties differ, I'm gonna return false, obviously, because it's not equal. Otherwise, I'm gonna return true. So now if I save this, there is nothing to generate really. Let's see, struct, and I'm gonna add string for types all. So I have this extension foo, I have the static function. I can move this here so it's the same line. So if name is equals, if left name is equals to right name, I'm gonna return false. If I'm gonna add if someone adds a new property like surname and it's still string, then it immediately gets updated. It immediately gets added. If I add a property that I cannot compare yet, like custom enumeration, so like I do enum something, case foo, and then I do something, something. I don't have written equality for it yet. Like the template here is simpler than what's bundled in Sourcery. So let's say I don't really care about it because this is just a transient property. So I can just write Sourcery skip equality, and it disappears. So you can tweak your templates. What I recommend doing is not doing it as an opt-out, rather for like the types. So I don't want every structure to be equatable immediately. What I prefer to do is I prefer to create a marker protocol, so I can add a new file only while the demo is watching. You can add new files, you can add new templates. So what I can do is I can add a file, and let's call it markers. It's just a Swift file, and here I'm going to do protocol auto equatable, which is empty. It's just there for ease of use. So now I can get IntelliSense, I can do auto equatable, and here I want types implementing auto equatable. So if I remove this, there is nothing to generate. What's interesting is if I add another struct with multiple properties, it's not going to generate the code for me unless I tell it to. So nothing changed, but the moment you do this, you have another property which is convenient. So you have boo and then you have foo. So it's very easy to use. You can do a lot of stuff. Like I can actually show you, while we still have time, how much code it generated for the New York Times. Even the equality. So I have this auto equatable code here. And now, so 1,200 lines for equality, 700 lines for hashability. We have a couple of enumerations, so not that many that we need cases for. And this is just like very little. Sourcery itself, which is interesting, it generates its own code. So if you look at Sourcery source code, it uses a lot of templates, and we go here, code generated. So it generates NS coding. This is all inlined. So after it generated, it inlines it into files. It has basically, when you interact with Objective-C, which is what we do internally in Sourcery, you don't get protocol extensions working as in Swift, so you have to duplicate the code. So we co-generate that code. And for diffing, for the properties, it generates a couple hundred lines. And this is what allows us to get those test level property differences. Equality, we generate equality, another couple hundred lines. Description, another couple hundred lines. We even generate JavaScript exports for EJS templates. All of this is done from a couple of lines of templating code. It's generated for you. When contributors to Sourcery work on it, they just work on the types. They don't deal with that. It's automatically updated for them, which is very convenient. And let's finish it up. Sourcery is available on GitHub. So you just go to my profile. under Sourcery. It has 38 contributors, so it's not relying on me being alive. Actually, people are, Anton and Ilya are doing more work on it than I'm doing right now, and there are other contributors sending PRs constantly. We had 39 releases, so it's also very often updated, and it's all free to use. Eliminate your boilerplate, write it once, test it once, and limit human mistakes. That's the core of it. Like, avoid anything that is boilerplate, anything that's repetition. Don't put it on us. Don't put it on other developers in your team. Just make it automatic. Just make it easy. And that will help you ease the maintenance costs. So you can create better architecture. You can work on the things that you care about, features, not boilerplate, not writing equality. No one likes that. It's not very nice. And if you don't trust me, here are some quotes from people that use it. I like this one. This one is cool. So you don't have to trust me. Like, try it. I think it's gonna be worth your time, and I really believe that it will save time for your whole team. Thank you.
Thank you. It was really, really awesome. And we have time slot for several questions. So
Krzystof, thank you for a perfect speech. As I understand, metaprogramming is a really cool feature. But let's assume that I'm starting a new project. It's easy. If I want, I can use it. Otherwise, I don't use it. But what about legacy projects? So, is there any checklists or requirements to understand that I can use metaprogramming legacy project or I can't?
Okay, so it's easy to start with it. How do we deal with if I have an existing project? Okay, so opt-in rather than automatically being opt-in, that's a big difference. So you can keep the equality you have, although let's go back to that in a second. If you use the protocol markers, every new type that you create, you just mark up, okay, auto equality, auto hashing, auto diffing, whatever. Like, you can use a lot of automatic protocols. And what's interesting, because it's doing AST, so it's not relying on the string, it's really relying on the protocol conformance. So what you can do is you can do a protocol composition. So you can create a protocol called data model object. And that data model object might be conforming to auto equality, auto hashing, auto coding, auto something. And then if your type implements, you just mark it up as a like auto model, and it will implement all of those. That's a nice feature. So if you do that, then you fully control what's generated for you in your legacy project, so you can use it for new types until you feel safe about using it for the old ones. The other thing is you can do is you can just remove the old code and generate it automatically, because it should be the same, right? The thing is, you should be committing those files into your project, the generated code. It's not like assets, like maybe for SwiftGen people don't embed it into the project. I think this is, because this is real source code, this really runs on your production app. It should be committed and it should be reviewed in pull requests. So what I would do is, maybe for start, if your team is big and they are like not sure, you all should always do opt-in, but do it for the new types. When people see that it's working correctly, that the template you are using is generic enough for your needs, convert the old ones. Because the thing is, if you go and modify that legacy model object and you forget to add the property, you have the same bugs, right? So if you can replace it, like, I think it's a good idea. And the code you generate is, even if you remove Sourcery, it's still going to work. It's just going to be, it's basically like reformatting your code, really, if you already had equality. So maybe it's going to be a different style because you decided to use guards rather than multiple if statements.
Thank you. One more question, or maybe two more questions. Let's start from the temp. Yeah, the great t-shirt.
One of the most repetitive boilerplate part of every project I find is writing the remote API consumption layer. I wonder if you found some good ways to automate that, maybe the help of Sourcery as well.
You mean consumption of the remote data?
Yeah.
Okay, so I think Caleb Davenport was trying to use Sourcery for like generating the parsing code. So if you have an ability to use something that's very specific, like a protocol buffers, that probably would be better, right? That generic purpose solution. But you could easily like JSON decoding. I think there are templates on the repo that do it. There's definitely a couple of templates that other people wrote that do data parsing using Sourcery. So it takes your type and it generates the functions to convert it from NS dictionary or dictionary right now.
I wonder, like, have you got a specific approach that you use every time, or like a library? Like
so yeah, I usually use Unbox, which John Sandel wrote, because it's very simple, and I just co-generate that part.
Thank you.
Sure.
Thank you. Any more questions? Yeah.
There's one more. Yeah.
So my question is, you said write once, test once. How do you test the templates, or you test the actual code?
So what we have is, even for our own templates, we bundle test data with them. So as we update Sourcery, we make sure that it doesn't break. And you basically generate corner cases. So for like when you design the template, you can see, okay, so if this is skipping a property, or if it's this is a different if statement branch, we just generate data sets for that. We keep that bundled with the templates, and we just run it as an extra build phase to verify on Sourcery. So you could do the same on the project, or you could just have, basically just have the data in code and compare the results. Something like that. It's pretty simple.
Thank you.
Sure.
Super. Thank you. Any more?
Hello, Krzystof. Thank you for such an interesting topic. It's very rare to hear about this, about metaprogramming in Swift. My question will be, what was the most interesting template you wrote for Sourcery and that you used maybe? It may not be used in production, but more interesting, maybe the most complex one.
Okay, so time saved would be a good argument, right? So which one has made my life easier as a developer? And honestly, I think the diffing one, because I do TDD at the New York Times, and in Sourcery itself is test-driven. So it's extremely annoying to have to read a wall of text and figure out what's wrong, right? What's expected versus what's there. So that one was very simple to write. It was like a little bit of real Swift code for the custom matcher and a little bit of code generation, but it saved me crazy amount. It saved everyone working on Sourcery, so it scaled to 38 contributors. I mean, I think it's the most. Wasn't hardest, but it was the most influential one. I think things like Linux main are useful for the Swift on server people, and obviously equality in hashing is applying to everyone, because not everyone does TDD, but everyone needs equality sooner or later.
Thanks for a great report, and I wanted to ask some theoretical questions.
Sure.
So, metaprogramming is about avoiding human mistakes and avoiding the templating and boilerplate. So, there are a lot of architectural approaches for iOS, for example, that actually require boilerplating. If we apply some metaprogramming ideas to these architectures, wouldn't be harm for these architectures. So, couldn't it break the idea of these architectures that require boilerplating? It's
Can you repeat the last sentence? I think I lost you at the last sentence.
If we apply some of the metaprogramming ideas to remove human mistakes and boilerplate to architectures that require boilerplate.
Okay, yeah. So one of the examples is the typed identifiers, right? It's a nice architecture idea because it creates stronger contracts on your functions. So you cannot pass something that's a different data type, even if it's underlying it's string. So like people use strings for emails, passwords, and all the other properties. if you just use strings, you could make a mistake and pass in password as an email, right? If you use type identifier, that's impossible because it has to be created specifically for the use case. So you could code generate all the boilerplate related to using type identifiers because Swift doesn't have some types. It doesn't have some of the features that languages like Haskell or Scala has. So that's one of the use cases where it could be used for the architecture improvement and limiting the boilerplate. The other is, for example, I have an article about protocol composition, and the idea is there for making dependency injection easier. That's another use case where you can code generate most of the boilerplate, so make it easy to use, but also make it hard to make mistakes. So I think there's a lot of things you could use it for to improve the architecture.
Yes, but imposed of very strict control of the idea, right? You must have really strict control on what you're optimizing.
Well, I mean, that's true to anything you write, really, right? Like any code that we make a decision for the architecture, but I think the only way to avoid people making mistakes is to make it easier to make it right. So that's the best we can hope for, because if I have a team of 10 people and I can design the most beautiful architecture, there is no way in hell I will be able to review every single line of code that they write, right? So there is no way in hell for me to ensure that they follow the architecture. They can only ensure themselves, and the only thing I can do is I make it easier for them to do the right thing rather than doing the wrong thing, which is why people use singletons, because it's easier than using dependency injection, unless you use an architecture that reverses that relationship. So like if you use flow coordinators, you already get all the dependencies injected, so you don't need singletons. It's actually harder because you would have to create the singleton first to be able to use it. So that's, I mean, it's always going to be a question, right?
Thanks.
Sure.
Thank you. Let's wrap our question section. And this is a complicated choice for you, Krzystof, sorry. You need to select one question that you like most, or maybe that you remember at least.
I think the legacy one is good because it's what most of you like. Most of you don't use Sourcery yet, I guess, so that's most applicable. How do you start using it? Yeah.
Thank you. So thank you for your great talk. This is a small gift for you.
Thank you. Thank you for listening.